Okay, so let's take this and we'll print out the answer because all of these just return something. So we need to print it to see what it's going to do. But let's say I take the number 13.0001 and I change it to an integer. What do you think the answer is going to be there? You think it'll be 13? Let's see. That works. What happens to the 0001? It gets dropped. And that's an important distinction because it could be 13.9. If we round 13.9 to the nearest whole number, what is that? Because 13.9 is almost 14. But if I run that, it still just drops it. So I'm dropping almost a whole number there. It doesn't even matter how close I get to 14, right? This is very close to 14. For all intents and purposes, it is 14. But when I run that, oh, wait a minute, what's going on there? Right? So there is some threshold there where it says, hey, wait a minute, that's 14. What is the threshold? It's right around there. Okay? So if we click this and run it and we do a little experimentation, so we got 19, we keep adding a 9 here until it says 14. Right there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. It's in the quintillions somewhere. Quintillions. So you got to get really, really close to 14 before it says, but man, I thought computers were precise and exact and did the same thing consistently. Oh, nope. That's what makes them so weird and fun. And that's what makes, like, when we get an error on our computer, we're like, man, why isn't Windows just doing what it's supposed to? Why does it feel like my computer hates me sometimes? The reason for that is because computers are so complex. Just like ChatGPT is just another computer, just like this. It's just doing calculations like this. But it feels like it's human almost, right? When you talk to it. So what's going on there? All we have is just a sufficient level of complexity. It's so complicated what's going on there that it starts to take on almost a personality. Because even at this level, even with these nines out here, it's a little bit annoying, right? That it does that. Because either it should drop them all the time or it should always round up. But it doesn't. And it comes down to what we call differences in processing speed. In fact, because sometimes it does that calculation and it comes out one way and sometimes it comes out the other, but only at a very, very precise level. Okay, we're talking, quintillionths is not a joke, right? So it's a very, very tiny thing. So if I take this and make it a string, that's interesting, right? What is it doing there? It is converting it to a decimal, and then it is how about that, guys? It's a little annoying, isn't it? That it does this. Now, how often do you think we're going to be calculating at that level of precision? Never. Well, not never, never, but almost never. But it's something to remember that at that level of a fractional piece of something, we get some weird behaviors going on. So this is converting that to a string. And so there we go. That becomes a string. But at some level, if I keep adding nines, look at what happens here. That's weird, right? And then I add one more 9, and it becomes 14.0 as a string. So just sort of not something you have to memorize how many places out this happens, but that at some level of very small precision, when we're doing type conversions or even mathematical operations, the computer will actually do some unpredictable things. It loses its precision at that level because it's just too small of a piece. So here's the big question. Is 13.999 whatever, is this true or is it false when I convert it to a Boolean?
False.
You say false? How many say false? How many say true? How many don't like to take risks? Okay, there we go. Okay, so this comes out as true. What about that? True or false? Also true. What if I go less than 1? What if I say something really small?
True.
Okay. What about this? That is false. 0 is false. What about, I won't take it personally, but is this true or false?
Would it be false because it's not equal to something?
But it is equal to something. It's a list of characters, right? So it's not equal to anything mathematical. So this comes out as true. Let me test your thinking here. Okay, so the number 0 is false. What about the string? 1 character, 0. True or false?
True.
You say true? I say true, because a string is a list of characters. It's not a 0. It's not a nothing. Even though it has the character 0 in there, that's still a character, just like any other character. True or false? Empty string. We're going to say false on that one, and you'd be correct. False. So, lots of weird, when you go from one type to another, lots of interesting things can happen. And can I go, what about this? Int, we go here, that gives us an error. Now, I can do an integer from 19.23, and I can take 19.23 as a string, and I can turn it into a float. And I can also, if I take that float, I can turn it into an integer using 2 steps, but I cannot go directly from a string that has a decimal to an integer. How are you going to remember all this stuff? It's so crazy. The exam's going to be just really difficult, isn't it? That's why we don't have exams, because exams are not useful in programming. Okay, now I know this is really hard to see, but also it is available online for you, and it's also really easy. I actually asked ChatGPT to generate this for me, generate a matrix of conversion from one type to another that shows me what will happen. So this will tell me, obviously, if I change an int to an int, or a string to a string, or a float to a float, or a Boolean to a Boolean, no change, doesn't matter. But this will tell you if I take an int and I make it a string, it just converts it to a string. It gives you a little example. Convert an int to a float, no problem. Convert an int to a Boolean, tells you if it's 0, it's false. Always, otherwise it's true. Okay, so these, you'll notice that converting to an integer does not often, it doesn't really give me any errors. Or converting from an integer, it does not. Converting from a string is perilous because converting from a string, it's going to give you an error for most types except for Boolean. But float and int, you got to be very careful converting. And here we go, convert from a float to something else and convert from Boolean to something else. Boolean, if I convert from a Boolean to an integer or a float, always just becomes a 1 or 0. Easy to remember. And then when I convert it to a string, it becomes either the string true or false. So that's a good table to consult if you're trying to remember what's going on when we're converting from one to the other.